Hey guys, welcome to day 2 working with spatial data in Databricks. In order to um, calculate the distance between 2 points on Earth, the Earth has been divided into vertical and horizontal lines. The horizontal lines are called latitude and the vertical lines are called longitude. At certain point, there is always a point is represented by a value in latitude and longitude. For example, like this. 66 degree and 34th hash is a point um, at certain place on earth. Spatial data can come from multiple shapes and formats. GPS coordinates, which represent any point, then polygon, which represents certain area, region boundaries, GeoJSON. It's a special format of JSON. We'll see in one of the example. A well-known text, WKT. Databricks introduces two powerful spatial data types. One is geometry and another is geography. What are they? Spatial data has become an essential part of modern application, but not all spatial data is created equal. Some of it tracks store location in a shopping mall. Like within one single shopping mall, what are the different store location? Some tracks airline routes, like long routes where we are calculating the distance between two cities. When we are calculating a smaller distance, like a distance between two store location within a shopping mall, we don't need to consider the spherical nature of Earth. In such cases, geometry is good enough, or geometry will give the accurate result rather. On the other hand, uh, the the if you are calculating like distance between two different cities, we have to consider the spherical nature of the earth, because we can't find the distance like just by drawing a line, straight line, correct? In that case, we also have to consider the spherical nature of the earth. Then in that case, it becomes a geography problem. So let us try to understand by definition. Geometry is a flat world. Geometry type is based on flat two-dimensional view of a space, like a sheet of paper or a CAD drawing. It assumes that world is flat and allows you to define how you want to measure space in meters, in feet, in units of a projected coordinated system. Because it uses flat math like Cartesian geometry, operation like if you are trying to measure a distance between the geometric points, the calculations are completely different, and they are rather fast as well because entire Cartesian geometry comes to your help. Drawing a building layout using CAD system or mapping road networks within the city, if you are trying to find out, then definitely geometry is the way to go. Defining plots of land in land registry system or creating an interactive map of a mall navigation or festival layout planning. Geometry is the perfect way to represent. Whereas
Geometry,
geography, the real world, uh, brings in the spherical nature of the earth. It stores the data in latitude and longitude, and while performing the calculation, it won't draw a straight line, but it will use uh, something called geodesic math, the kind of math used by GPS satellites. This means you get accurate real world distances even across long stretches of a planet. The typical use cases are calculating the distance between New York and London during the for a flight route planning, right? And finding the nearest warehouse to the customer anywhere in the world. Mapping hurricane map or climate impact zone for a real world scale. Analyzing shipping routes across oceans for logistic optimization. In all these things, we cannot consider the flatness, but we have to consider the spherical nature of the earth. Then only the distances will be accurate. We need both because there is a trade-off between precision and performance. Geometry is definitely fast because it's a Cartesian geometry, so it is straightforward and very easily to calculate as well, and flexible, ideal for drawing blueprints and local data. But geography is accurate on a global scale, correct? And modern application often needs both kinds of tool depending on the context. So we have to understand the context first and then apply. What are the different set of type of data that gets ingested in the lakehouse. They can be raw data which is represented by something called latitude and longitude. You can build a point. So there are different data types that are possible. Um, one can be point. Second is well-known text, a text-based geometry format, and a well-known binary. There is something called GeoJSON. For all these things, we'll see examples one by one, which I have created and also worked upon in Databricks free edition. Okay. Let us start with our first example by creating a point column using latitude and longitude. Um, before or let us understand the uh, code first, and then we can understand what is SRID. Okay, so what is represented in front of you is a data. So as I said, on Earth, when you are talking about the any point on the Earth surface, it is represented by something called latitude and longitude. So we are assuming that there is a store and its point location is represented by latitude and longitude. Similarly, there is store B and its point location is represented by latitude and longitude. So like that. So this type of data is coming. What we can simply do is we can create a data frame out of it, and from data frame we can convert it into a column with the name called location, and there is a function which converts latitude and longitude into something called point. Point represent any point on the surface of Earth. So if we use this function called stPoint, which is provided by Databricks for natively for Lakehouse, and provide longitude and latitude, it is going to create a geometry data type. So now if we check the data type of the column location, it is going to be geometry, and internally represented by something called point. And point, as I mentioned, will have two dimensions. One is latitude and second is longitude. In that we see a word called SRID. What is SRID? Let us try to understand that. SRID stands for Spatial Reference System Identifier. It is unique number used to identify the coordinate system and projection method a spatial object uses. Each SRID defines how coordinate relate to the point on Earth. What units are used for calculating the distances, whether it is degrees or meters, whether data is 2D Cartesian projection or it is considering Earth curved surface. If your geometry has wrong SRID, spatial function like distance, area, intersect can return incorrect result. So it is extremely essential that the SRID should be correct. So right now SRID 0 means it is just a simple geometric shape. Okay. Then let's move to the next one where we are trying to create a geometry polygon from well-known text. So suppose we have received this data, like there is something called zone 1. It's not a point now, it's a polygon. Uh, it's a location with multiple points, we can say. So if you have received something like a polygon with multiple latitudes and longitudes, what we can simply do is we can use a function called geo geom from WKT, like geom from well-known text. If you pass these polygon coordinates to geom from well-known text, it is going to convert this particular data into something called geometry, but that is going to represent a polygon inside it. So earlier we have seen it's a data type is geometry, but it is having a point. Now this time, since it is representing four different coordinate four different coordinates, so we can say that it is a polygon. Now this code defines two regions as well-known text polygon strings and loads them into Spark data frame. Using stgom from WKT function, it converts the WKT well-known text into Databricks native geometry type, which is required for spatial analytics. The expression function let us use the SQL expression in PySpark to create boundary column. That is also called a boundary column. Once converted, the geometry can be used for spatial operation like distance calculation, intersections, and area measurement. So this is how it works. There is this third data type by which the data can be ingested is GeoJSON. It's a uh, JSON modified to contain coordinates which is latitude and longitude, and it works like this. So there is a JSON which has first column representing the city name, and within city there is a point of there is a there is a coordinate coordinate of a point which has latitude and longitude. Similarly, there is another city called Paris, and within Paris there is a point which has coordinates latitude and longitude. What we can what we can do is we'll create a simple data frame, and let's call the columns at city and GeoJSON. Now what we will do is, since it's a point coordinate, we will use function called stgeom. Geom is geometry from GeoJSON, and we'll pass this GeoJSON. It will create a column called geometry, and then with column we can even add another column called GEOG. It's a GEOG. It's a small one-letter difference called GEOG from GeoJSON, which will convert the GeoJSON point into a geography data type. So once the data frame is created, we can simply run show on that, and let us see how it is created. So now this is a GeoJSON, and we have read a point, and now the point is converted into uh, two columns called geometry and geography. Within that, a geometry data type is being stored. You can see the data type geometry, and a geography data type is stored. So GOM is a function, GEOM is a function which has created something called geometry data type, and then GEOG has created something called geography data type. And while creating geography, since we consider the spherical nature of the earth, therefore a spherical word is present. So within the same delta lake, you can simply go and store this data, and then if we run this, we can simply store this data, and then let us run the select on top of it. Since I have not ran all these things, so let us quickly run, and let us create something called df parse. Data frame parse will be created. And now let us save this as a table within the same delta lake. Since earlier these geometry and geography were not present, then you would have to store it like a text, and then or maybe use a different database or some libraries to manipulate all these data. But nowadays, since natively geometry is available, you can directly use the functions. There are almost 80 plus function. Next video I am going to create, I will talk about as many function as I have tried. Okay, we have tried a couple of functions already, like GeoEM from GeoJSON is a function, then stPoint is a function, then stGeom from GeoG from, that is geography from JSON, is a function. So like that. Now we'll just simply uh, store the data frame into a native delta table, and then let us read that data table and see how the data is stored. So city, and you receive this GeoJSON, and it is converted into a symbol is geometry, and here the symbol is geography. The data it is being converted into a data type called internally as a point, and then it is using something called SRID. SRID, as I already mentioned, is a spatial reference system identifier. Spatial reference system identifier. Sure. Like this distance is always the shortest distance, but considering the spherical nature of the Earth, it's not Cartesian. It's a spherical nature of the Earth. It is used for flight paths, high-level geographic calculation. But in reality, you may have to take the highways and also real distance might still be greater than the aerial distance. But aerial distance is the shortest distance that we can draw. Okay, the aerial distance between, let's say I try to calculate, like between Pune and Nagpur is 586, but by road it can be around much more, like almost 800 or so. So like that. The road distance considers the actual path you travel. Like we travel through highways, streets, and all. The real navigation route, it's always longer than the aerial distance because roads are no longer straight and you have to take the paths now, right? So real world logistics and delivery and fleet planning, we definitely consider the real distance, aerial distance, like just to get an approximate distance, right? Like then you can plan those things out. Now, in this entire video, you have seen the geography data type, uh, geo- geometry data type introduced by Databricks for Lakehouse. So you can do all these geography and geometry calculation within Lakehouse, and you don't have to take your data back and forth or use any special kind of library. Bringing this capability to Lakehouse brings a lot of new opportunities and make your lakehouse much more powerful. In the next video, what we are going to understand is like 80 different functions that has been introduced by Databricks for lakehouse for calculating the geometry and geography related spatial distances. Thank you guys for watching. Thanks a lot.